Hello and welcome to today's SQL Office Hours session. Today, we're going to look at a question that someone asked me after last month's session. They were basically said they had a SQL statement, and it looked a little bit like this. I'm generalizing a bit, but they had selecting from a table, selecting the row num, sorting some data, and then they were finding all the rows less than that row num, and then all the rows greater than that. So this is like a pagination query to get rows n through m. So we can get page 1, 2, 3, 4, so on and so forth. And they said, well, they got this query and it's running okay, except when we get to row 2 million, it's kind of slow. And I was like, row 2 million, right? I'm not shocked that this is slow, right? It's unsurprising to me that when you get to row 2 million, this query it suddenly takes a long time to actually process and return the data. So that's what we're going to look at today. We're going to look at why I'm not surprised about this, and look at things you could do if you're in this situation to kind of help tune and optimize your queries. So pagination's pretty common thing that you need to do. So let's look at that. So hi, everyone. I'm Chris Saxon. I work here at Oracle in Gerald Wenzel's app dev team. I'm here to help you get the best out of Oracle database and hopefully have some fun whilst doing so. So with that in mind, it's always great to be here for these SQL Office Hour sessions, talk about SQL, answer your questions, explore a topic, and see what we can learn and find out about it. So before we kind of jump into like that pagination query, I think we need to wind all the way back to the beginning and look at the basics of order by, because we need to sort some data. If we're going to do page results, we need an order by, right? And very, very first principle, most fundamental principle, and that is if you want sorted results, you must have an order by, right? There are lots of situations where it can look like your data is returned in the correct order, but often that's just by chance. So don't rely on just the fact that you've run a query and everything appears to be sorted how you want it. Make sure you include an order by. Without that, there are no guarantees. And the database might change its mind, might use a different execution plan, might run in parallel, something like that. And suddenly your data will not be in the order you want. If you want sorted results, you absolutely must include an order by. So with that out of the way, how does order by work, or how do we use it? Well, it comes pretty much, it's one of the last things in a SQL statement. So you've got your select, from, where, and so on. And then right at the bottom, we'll have an order by. And we can list out various expressions or columns that we're going to sort by. So this way this works, if we've got two things here, expression 1 and expression 2, excuse me. First up, the database will sort the values by that very first expression. So it'll start on the leftmost one, and then it'll work left to right through them. And then rows which have the same value for expression 1 will be then sorted by expression 2. And then expression 3, if there's still ties, and so on and so forth. So it works left to right through this order by, and it's only using the second and third and so on column or expression if there are ties in all the preceding values. And when we do this, by default, the sort is low to high. So we start from 0, go up 1, 2, 3, 4, A, B, C, work through the alphabet, things like that. Dates, we go from older time to new time. So from yesterday, today to tomorrow, that kind of thing. So if we've got a little basic data set like this, we've got a small table and we're ordering by expression 1 and expression 2. As I said, first thing the database does is it will sort the rows by expression 1. So we got our letters here, and we can see we got B in there a few times. So we end up with A, B, 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 C. So there are 3 rows with the value B. So the database then sorts those row values within that, or those rows, by expression 2. So we can see we get 1, 2, 2. So notice for that second column here, they are not in order. They're only in order with respect to this first column. So the tied values for expression 1. Another thing to note here is I've got 2 rows for B2. The order the database returns these is undefined. It can come back in either order. Now, this is the only columns in our result set. Probably doesn't really matter, or we can't actually tell which row is which. In reality, there's probably other columns in there as well. So if If the columns we're sorting on are not unique, or they're not part of unique, the whole of primary key or unique constraints, we don't necessarily know which order they're going to come back in. Could be any order. So that's a little basics on how we can order by. So to kind of flesh this out and look at this in practice, let's follow on from the example I used last month. So last month I was looking at the leaderboards for Oracle Dev Gym. So on Dev Gym, each week we have our competitive quizzes, and we publish the leaderboards based on how people did. So a basic way we can rank players is we can say whoever got the highest correct, the most correct, is first. And then for people who've got the same percentage of correct, we resolve ties by time, right? So whoever's fastest, the highest percentage, and then the fastest. So in order to run a query like this, notice we're highest percentage means we don't want low to high, we want high to low, right? If we just do order by percent correct, we'll end up with 0% being the winner. Doesn't sound right. We want 100% to be the winner here. So we order by percent correct desk. So we can use the desk keyword, and that flips the sort order from high to low. So 9, 8, 7, 6, 5, and back through the alphabet, so on and so forth. So that is the first column we're going to sort on, and then we're going to sort on time ascending. Now I've got the ask keyword here. Technically, this is optional. It is the default value, but it can be useful to include it just for clarity, should you wish to, particularly if you've got several expressions and you're mixing and matching ask and desk and things like that. So that goes low to high. So we sort our percentage and then our time. So do this and we'll run the query, and we might get some results that look a little bit like this. You're like, well, hang on. Why are all those nulls at the top of the data set? Okay. So with DevGym, it's possible that people could start, it's just an internet-based thing. People could start a quiz, but not actually answer it. So they might not actually have a result. They've got no percentage because they never got the answer here. So they have a null percentage of correct and null time. So why are these values at the top? Why are these nulls appearing here rather than 100 or whoever had the highest score at the top? Well, when you have a descending sort, then the nulls are first in the result set. So in ascending sort, low to high, nulls are considered last. So they will appear at the bottom. With the descending sort, nulls are considered highest, all right? And they're considered first. They go to the top of the result set. That's not what we want here at all. So we want to push them down to the bottom. How can we do that? Well, we can add the desk. After the desk keyword, we have the nulls last clause. So that forces the nulls down to the bottom, and it overrides that default. So we've got percent correct, desk nulls last, and then we've got sorted by time, ask, and then nulls last. So again, for the sorting by time, ask nulls last is the default. We don't actually need to explicitly specify this. You might want to do it just for clarity and just help people understand what's really going on here. So we can do that, and now we'll get something a bit more meaningful, something that looked correct. So we got something like this, 100% correct at the top, and then sorted by time. So we can see only one person got full accuracy, various people with 99% correct. But, we're looking at this and we might think and say, hang on a second. Well, the first person who got 100% did it in 345 seconds. So well over 5 minutes. Person who got it in 99 seconds took just 30 seconds, like 10 times faster. Do we really want to put percentage correct so, weight it so heavily and say that percentage correct is the most important thing? We might go, well, actually, we kind of want to blend it a bit, kind of a ratio, and take into account how quick someone was and not just how accurate they were. After all, like I say, this is an internet-based quiz. You could always look up stuff in the documentation or try something out yourself. Someone who's taken half an hour might have actually, typed out everything out and run the stuff themselves. So we want to give some weight or a bit more weight to the speed. So one way we could do that is just divide the percentage correct by the time, okay? So we're going to call that our score. So we can have that expression in the score in our select clause, and we can also order by it as well. So we're going to sort by our score. And again, it's descending nulls last. because, higher values, higher percentage of correct is going to have a higher score. So selected our score and we've sorted by its descending. So we do that and we'll get a score like this. And our top score is 93% in 31 seconds. I was like, okay, that might sound reasonable. But if we look at some of our other results, our next few results, we're finding that whoever's second had 70% correct. Whoever's third had 65% correct. And it's like, these people were pretty fast, right? But 65%, that's 2 in 3, 2/3 accuracy, roughly. Is that really better than 100% correct? We've probably kind of pushed things the other way. We're giving too much weight to time and not enough weight to percentage correct. So rather than doing that, rather than weighting by percentage correct fully, let's tweak the formula again a bit, and we'll say that we'll square the percentage correct. So basically, the more accurate you are, you'll score exponentially higher, and we'll take the square root of the time because, we still want to reward people for being fast, but, we don't really care too much the difference between someone who takes 15 minutes and 20 minutes, for example. So we'll change that formula. So we've got our square formula and we've got the power and with square root of our time, and we'll run the query and get something that looks a bit like this. Okay, so we've got our scores here, but all right, I forgot to do something here, right? I've updated the score. I selected that expression, but I forgot to update the order by as well. We still had it just percent divided by time rather than percent squared divided by time. So we notice that this score, this fourth score here, should actually be third, or at least above the row above it. And this can be a general problem, right? In this query, there's only a few lines in it, but imagine it's a much bigger SQL statement, and you're selecting some kind of formula or calculation, and you're sorting by it as well. They could be, if it's a 50-line SQL query, they could be like a page apart. You might fiddle with one and forget to change the other. It's not really great, right? Ideally, we just define this in one place. So if we change it, it just all flows through. The good news is you can do this by sorting by alias. So we can select our formula here in project in the select clause, give it an alias, the score, and then sort by that alias. So now if we change the score, change this formula, it's automatically reflected in the order by. It's pretty useful, right? So we don't have to worry about keeping these things in sync and accidentally forgetting to change one when we should have changed the other. And I'll do that, and we can see now, okay, this is starting to look a little bit better. We've got people in the high 90s, second, third, and fourth, and so on. And maybe we might want to tweak this formula a bit more, but it's a good basis to kind of work from. So at this point, I'm going to jump over to a little demo and just kind of show these things in action and just run through these and see how they actually work in practice. So we've got the order by basics, and let me just check I've got everything set up and running. So just quickly, for those of you who aren't aware, what I'm using here is the Oracle SQL Developer extension for VS Code. So Microsoft VS Code, a very popular tool, has recently released an extension for it for SQL Developer. That's what I'm using to run my demo here. So first up, let's just do basic sort. We're going to look for a particular quiz and just sort by user ID. Notice ask is in commented out because that is the default. I'm just kind of showing going. I'm going to make sure I wave my arms around in the correct way here. I'm going low to high. I'm going up. Okay. So we do that. So we can see user ID 720 is the lowest ID, and you can see they're kind of gradually increasing up through there. And if we change it to desk, we go the other way. We go high to low. So user 99885 is the highest, and we go down through our data set. So far, so straightforward. So now let's sort by percentage correct. As I said, it's quite likely, in fact, almost certain, certainly if you've got more than 100 people take it, you're going to have at least 2 people have the same percentage correct. You can see there's multiple rows with the same percent correct here. And because we've only sorted by that, the order for the other columns is, or the rows, is undefined. Notice that these user IDs aren't sorted. So we got 67,000, 84,000, 23,000. So up, down, up. Again, the time, 233 down to 107, up to 200, 129. The dates all over the place as well. So if the values are equal for this, we don't know what order the rest of the rows are going to come back with respect to the rest of the columns. So let's add in seconds taken. So now we can see, okay, we've got 0, 1, and we're going up through the percentage, the time taken, 107, 129, so on. So we're ascending through those values. Now, it is, of course, possible that two people have the same percentage correct and take exactly the same amount of time. It's unlikely. I mean, it'd be unusual, but of course, it's entirely possible. And of course, how we handle that and what we decide to do about that is partly a decision, a ranking decision. You know, do you have like forced ranking and say always 1, 2, 3, or do you do like the Olympic ranking? A lot of sports, if teams are tied, have the same score or result, they're considered to be in the same position. You know, there's some Olympic sports where people can tie for bronze, or two people can have the same outcome for silver. There's going to be two people who get silver. So that's kind of a business decision about what we want to do there in terms of who wins, or are they equal. Okay, so we can do that, but that's then, so sorting by percent correct and then seconds taken. Now, of course, that wasn't actually what we wanted for saying who was best, who was the winner. We wanted the highest percentage correct, right? So let's put our desk keyword in there, and oops, all these people who didn't finish are at the top of the result set. So we need to push those down in the data set. And we can do that with our nulls first. Sorry, that's not what I'm saying. This query above is equivalent. So these two queries are equivalent. Just desk and seconds taken is equivalent to desk nulls first. That's why they're at the top. And then seconds taken nulls last. Now, because we've sorted percent correct nulls first, seconds taken nulls are also at the top because we've got those null values first there. All right, so we want to push these percentage corrects to the bottom. We need to make that nulls last. And again, we can put nulls last here, but technically it's optional. We don't actually need to add this for the seconds taken. And there we go, 100% correct is at the top. Excellent. All right, but let's tweak this. Let's use our formula. Percent correct divided by seconds taken. And again, we can see, so we've got our score, which we've computed here. So score 3, 2, and so on. And as I said, person who's got 93 is at the percent correct at the top, but we're probably putting a bit too much weight on the time. People who only get like 2/3 correct are scoring very highly. Not really what we want here. Okay, so let's change it. So we square the percentage correct and take the square root of the time. So we've got our new scores here, but oopsie, I forgot to update the order by as well. Very easily done. Like I say, with a 4-line query like this, I'm sure most of us would spot this, but like I say, imagine this is actually like a 50-line query, and it doesn't even fit on one screen. So we've got a page. Very easy to update one and not the other, or to update both and make a slight mistake and not quite apply the same update. So rather than doing that, we can then order by the score. So now I'm going to use the alias here, and we get the result that we're looking for. We're sorting by score. And the nice thing is, because I've used this alias here, let's say we want to change this. So we can see we've got people in the 80s in positions 5 and 6. Let's say we want to give a bit more weight to the percentage correct. So rather than squaring it, we're going to give the 4th root. So give percentage correct an even higher weight. We can change that. And yeah, we can see where people in the 90s are now coming up higher in the results. The key thing here is I can now fiddle around and change this formula however I want. I can change it to cube or whatever. I could change it to, make it a fractional value or something like that. That's making not what I want to do there, but I can fiddle this, and the score changes and the sort then also changes at the same time. So we've got one place to change the formula and set it. So any questions or comments on this before we go on? Like I say, this just covering some of the basics of how to use order by, because this is pretty fundamental for understanding how these top N and pagination queries work. You know, we've got to sort the data you've got to have that order by to get the sorted data results and actually get the top N. Without this, the database is free to return the rows in any order we want. All right, I'm not seeing any questions or comments at the moment. So let's just kind of recap that. And like I say, by default, with order by, we have ascending, which is low to high. You want to change that so the highest values appear first, put a des keyword and put something in. So if you do have a question, just type it, right? Just type your question and I'll read it and answer it best I can. So please just type your answers type your questions. It'd be interesting if you like type the answers and I have to guess what your question was. What's going on here? Okay, so then they say one of the things here to watch for is null values. Okay, so if you have an ascending sort, then the null values appear at the bottom. And if you're a descending sort, by default, the null values appear at the top. Quite often, that is not necessarily what you want. You know, if it was a decision made back in the day, but if you want null values to be at the bottom, then you need that null's first last, or change where they appear, that null's first last keyword. And finally, if you have formulas you want to sort by a formula, and particularly if you want to select it as well, so you have it in the select clause and the order by clause, use the alias the formula, and then sort by that. That avoids them getting out of sync and kind of inconsistencies that can cause. Okay, so I see there's a few questions coming. Question, which Oracle version? I mean, order by has been around basically forever, since the beginning, as far as I know. And all this stuff, it's been around longer than I've been using Oracle, let's put it that way. And I've been using Oracle database like 20 years. This is all very well established, baked into the database stuff. I don't know which version it came in because it's so old. If you're using a version where this stuff isn't supported, then you need to get in touch because you're like using the oldest version on the planet, probably, right? I can almost guarantee all this stuff will work on whatever version that you're using. If it isn't, then wow, I'm shocked, right? Okay. So there's a question, what if you excluded the nulls using the where clause? Is that more or less performance? So we'll come, I mean, in terms of the sorting, I'll talk a bit more about performance in a minute. So like I say, I want to cover some of the fundamentals of just how order by works. We'll look at some of the performance aspect of it. But a where clause will affect performance because it affects what indexes the database uses. So probably keep that question in mind and we'll come back to this, right? Because there are some interesting things to be aware of, okay? This where we're giving alias in the order. Yeah, alias in order by has been around a very, very long time. I don't know which version it came in. It's been around a very, very long time. Okay. Like I say, everything I've shown you so far works on, I'm sure, every version of Oracle I've ever used. Okay. Alias in the order by definitely has been around a long time. Okay. So it is not a 19C feature. Let's put it that way. So that's an question. Will joins have a conflict on the order by? No. So the sorting is one of the last things that the database does. Okay, so you access your tables, join, filter, where clause. Sorting is pretty much the last thing that's done. I say pretty much because the stuff we're going to talk about in a second is actually the last stuff that happens. So the joins won't kind of conflict with it, but they might affect how you write the order by, because of course you might end up with more duplicated values than you would otherwise. But it's done, the sorting is done after the joins. Okay, so columns, yeah. Those of you claiming sort by alias wasn't possible, you need to kind of show me that it's not possible. Like do a select from $V version, because this has been possible for a long time. I'm pretty certain. Someone saying they started with Oracle 4 and nulls were considered the lowest, then this was changed. I don't know. Yeah, I don't know when that was changed. That's been true for as long as I've used Oracle, as far as I know. But like I say, this stuff has been around a lot longer than you think. Okay. Okay. Alrighty then. So that's some of the basics. Um, so question about SQL standards, null values coming at the bottom, order by ask. So that's a good question. I can't remember whether it's SQL standard or not, but it is true that other databases do this differently. Okay. So I'm not sure exactly what the SQL standard defines for this, but other databases will have a different interpretation of whether nulls should be top or bottom. So do check on whichever database you're using. I'm obviously using Oracle database here, but if you're using something else, then just validate and check. And that, again, if you're writing something that needs to be database agnostic, that's a good reason to include that nulls first last clause. Alrighty then. So those are some of the basics. Let's move on to talk about top n queries. So we want to find the first 10 rows matching some criteria or according to some sort. So I said order by was nearly the last thing. This is actually kind of the last thing that in your SQL statement, the last thing it does, the fetch first clause. So fetch first was added in 12c. 12c is what, 11 years old now. You really should be using a version at least this high. This is where I'll do my general kind of get my high horse a bit and say, if you're using 11.2 or higher, you absolutely should have upgraded by now. Okay. If this doesn't work for you, the answer is upgrade. Okay. So the syntax, the query I showed you at first really should be switched to use fetch first now. So this has been around a long time. Okay. So we can do fetch first in rows. And you notice there's a big gap here because there's an optional keyword here, and that is percent. So you can say whether you want an exact number of, or up to an exact number of rows, or a fraction of the table. So we can say, I want 50% of the rows from the table, or I just want 50 rows exactly, right? 10%, 10 rows, whichever. So you've got that option to state whether you want a percentage of the rows or a number of rows. Next thing, optional clause here is this, well, not optional, choice clause here is, do you want exactly n or up to n, or do you want to include rows with the same value as the nth? So we've got 10 rows and we're on row 10 and we sorted by some things and there are columns after it, or rows after it, which have the same value for the order by columns. Do you want to see those in the results or not? Only means we stop at 10 rows or the 10%. With ties means include all the rows the same value as the 10th or the 10th percentage row in the output. So, as I say, this was added in 12c. It's been around a long time now. This is the way to do top n queries in Oracle database. So, question someone was asking about performance, how things there. So let's start thinking about this and start looking at performance. So the question here is, how fast is this, or what effects is the performance on these things? So the first thing, if you've just got an order by clause, the database has to sort all the rows, right? So if there's like a million rows in the table and you've just got an order by, it has to sort all 1 million of those, okay? Because we don't know and figure out which, where each row goes in the result set. Obviously, that could take a while. Sorting is generally one of the slowest things that the database can do. So sorting big data sets can take a really long time. However, when you've got a fetch first clause, it still needs to read all the rows, right? If we're ordering by some column and we've got a million rows in the table, we could get to row, the millionth row we read might be in the top n that we want to actually return. So we need to still read all the data, but we only really need to actually sort n of them, okay? So we've got 1 million rows in our table and we want the top 10. We only need to keep the top 10 in our result set. So to kind of do something a bit different to kind of demonstrate this. I'll just come off the slides a second if I can. I've got a big box of toys here. There's some who's seen my other videos might remember I play with my kids' toys all the time. Let's say I've got this big box here and I want to find the 3 smallest bricks that are actually in here. So there's quite a few. So obviously I'm going to have to go through them all to find which the 3 smallest ones are. So let's start. Let's pick the first one up. It's quite big. That's a car. Right, so that's the first one. Then we've got like kind of a brick that's smaller than that. Well, we're not up to 3 yet. And then we got a slightly smaller brick here. Is this one smaller than that? I don't know. Maybe. So I've got my 3 bricks here that we're going to sort. Now, I am going to have to check every other single brick in this box here. I'm going to say it's a big box. I'm going to have to go through all of them and check whether or not they're smaller than these. But I only actually need to keep 3 of them in my sorted data set here. So each time I pick a new one up, I just kind of really got to ask, is it smaller than the biggest thing here? So this white car is definitely smaller than this pink one. So I can throw the pink one away and we're down to just the white one. So let's pick up the next thing. Let's see, what's this kind of blue thing like this? Yep, that's smaller than that white car. We can throw the white car away. And is it smaller than that? It's probably smaller than that blue brick there as well. So that fits in there. So then I can pick up this next one. Yeah, that's bigger than that, so I can ignore that. So like I say, eventually I will have to go through all of these, but I only actually need to kind of sort or have a sorted data set of the 3 that I'm going to return. Okay. So just a little physical demonstration there. You can see, I'm curious if what you think about that, if you think that helps, is useful or interesting. So how can we see that in database terms? So we know this is happening in the database by looking at the plan. So we've got our table access full, and we can see there's like 999 million. There's a big table, nearly 1 billion rows in this table here. But we only want the top 3 of those. So we'll see this window sort. You'll see something that looks a bit like this. Window sort pushed ranked, and we're only getting 3 of them. So we're only actually keeping 3 of those rows in our sorted data set. But like I say, this is a big data set. We still actually have to read all nearly 1 billion of them, 999 million. So the question here is, how can we improve it? What can we do to make this a little bit better? Okay. Well, let's move on to, let's update the example, make it slightly more realistic. Here's a little example query. We've got where column 1 equals, we're almost certainly going to filter that data. It's pretty unusual. You just have an order by with no where clause at all. Can happen, but it's unusual. So we're going to find all the rows equal some column 1, and then we're going to order by column 2 and then column 3. So how can we improve the performance on this? Well, what we can do is create an index that starts with column 1 and then has the order by columns in the same order in the index as they appear in the order by. So we've got our index on column 1, column 2, and column 3. If we create that index, the database doesn't have to sort the data. It's like, what? Indexes are ordered data structures. So every time we add a new entry to the index, the database has to put it in the correct place, or at least B-tree indexes, which are the default, index in Oracle database and pretty much all relational databases, as far as I'm aware. So to kind of show this an example, let's just create a 2-column index. We've got a index on column 1 and column 2. So like an order by, it will sort the values for column 1 first. So we go 1, 2, 3, yada, 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 yada. And then for each of those values, we have column 2. So those are letters. So we've got all our 1s first and then A, B, C, D. So it's sorted by column 1 and then by column 2. So entries have to go in the correct location in the index. So if we have a where clause like this, say column 1 equals 2, and then we're ordering by column 2, database searches the index, it goes to entry number 2 in column 1, looks up column 1, and then it goes over to the column, inspects the column 2 values. Because they are already sorted, they are already ordered by column 2, we can just walk along the index, whichever way it's supposed to be, right, left or right. You're looking the other way to me. So we find the entries matching the where clause, and then just walk along the index for the order by columns. And where you can see this happening is in the plan. You'll see something like this: index range scan, yada yada, and window no sort stop key. And notice at every single point in the plan, we only read 3 rows. We've bypassed the sort entirely because the data set already matches the order that we want. Pretty cool, right? So let's jump into a demo and actually look at how these things work in actual practice. So I see there's some other questions or comments come in. Yeah, someone, alias for group by is pretty recent, 23C. Yeah, alias for group by has only just been added, but alias or order by alias has been there for decades. So yeah, that's what I thought. As far as I know, order for alias has been there, like say, the 20 years I've been using Oracle database. How is this different from limit? Limit isn't in Oracle database. I mean, that's how it's different. It achieves the same principle, right? The limit clause, other databases do use the limit clause to kind of do the same thing and get the top N. Fetch first is the SQL standard approach to do it, but fundamentally, principally, they do the same thing. Yeah, maybe the confusion is it can't be used in a group by. Yeah. Why is order by not allowed in union clause? I'll come back to union. Let's cover union later on. Okay. Alrighty then. So row limiting, like I say, fetch first was added in 21C. 21C? Yeah, I'm just 12C. It's been around a long time. Fetch first. And we're going to order by our percent correct nulls last, descending nulls last. So we're going to get our first 3 rows only. So we can see we're getting percent correct, 99%. Okay. Now, what if other people have the same percentage correct 99? Well, let's see. Let's add percentage correct with ties. And haha, in fact, yes, indeed, there are. There are 3 more people who got 99% correct on this quiz. Right. So we're including ties. So with rows only, then you know the maximum number of rows you're going to return is n, 3 in this case. Rows with ties, you don't actually know. In theory, everyone who took this quiz might have got 100% or 99% correct, whatever. We could return anything up from 1 row or however many rows match the where clause up to the entire data set. So you don't know how many rows you're going to get back with this with ties clause. But it does allow us to see that there are multiple rows who have the same value here. Now, this with ties applies to all the columns in the order by. If we add seconds taken to it, you can see those values are all unique there. We're back to only getting 3 rows because no one else has 99% correct and 233 seconds. It has to be tied for all the columns, not just the first column. Okay. So that's with ties, getting number of rows, or we can get a percentage. So 3% of the rows. Like I say, that is a fraction of the table. So basically counts how many rows our query returns, times it by our percent, 3 divided by 100. There are 309 rows for this quiz. So 309 times 3, blah, blah, blah. That nets out to 10 rows. And there we go. We get 10 rows in our data set. You know, if I check that to, I can change that to 10% or something like that. You can see we get 31%. Numbers check out. Okay, so we can get a fraction as well as a particular number of rows. All right, so now let's start looking at performance. Okay, so there is the primary key for this table is the quiz ID and the user ID. Each person can only take a quiz once, is what we're saying. And we've got that in our where clause, but that's not in our order by. So we'll run this and we get our results and we get our plan. So we've got 309 rows matching our search. So 309 people took this quiz and our order by, we're sorting and we get 309. We're sorting all 300 odd of those rows. Now, one of the things to note here is these memory columns which have been added. So this is showing you how much memory is being used to actually process this sort. The more rows we sort, the more memory the database is going to have to use. So let's look. If we do a fetch first 3 rows only, so here we add an unbounded top order by. If we limit it to the first 3 rows, we can see we get we still read all 309 rows, but we only actually sort 3 of them. And notice we are now processing a lot less memory. So 2K of memory versus whatever this was, so 90 something K of memory. So we're using a lot less memory. It's going to be more efficient, and overall this will be faster. So, if you've got large data sets, obviously if you need to return all the data, you've got to process it all at some point. But certainly if you're just kind of checking or validating, it's useful to have that to stop us having to read all the data. So as I say, we are doing that. We're getting all 300 odd rows, but we can do a bit better. So we increase that to 100. We will see we get 100 rows and we sort 100 rows in our thing. And again, we process a bit more memory. So as I say, we can do a bit better. So again, those of you joined me last month when we were talking about performance tuning, I had a bit of, here's some I made earlier for indexes. I made the indexes invisible, which means the database can't use them in SQL queries by default. This avoids us having to sit around watching me, twiddle our thumbs while I create a whole bunch of indexes here. I can just make it visible and the database can use it. So we've got quiz ID and percentage correct. So I did make that visible. So we got our quiz ID and our percentage correct, and we're getting 10 rows, and we get our 10 rows, and voila, there's our plan, no sort stop key, and we only read 10 rows. Notice the memory columns are gone because it doesn't actually need to use any memory for sorting it. We're just walking along the index. Fantastic. Okay, so we saved ourselves some work here. However, in order to do that, all the columns in the order by must be in index. And actually, forgot something. We do a descending sort and we do it desk. We see we've got nulls at the top. The database can do an index range scan descending because although it's stored low to high, we could have just walked down the index the other way. Rather than working through it left to right, we can go right to left. The database can traverse the index top to bottom or bottom to top. But as I say, if we add more columns to the order by, so seconds taken is not in this index. So suddenly, the database is going to go, well, hang on, I haven't got that data sorted, so I still need to actually do a sort here. And again, we're back to reading all the 300 odd rows, okay? So to really benefit from this optimization, all the columns in the order by must also be in the index, okay? So here's another one I made here. There's going to be quite a few of these that I've done here. So here's our index with all the columns in it. We'll make that visible and we'll run this again. And we can see we're back to only the data that we want, only the 10 rows that we want. Nice big saving there. Okay. But there is a bit of a challenge here. So far we have been sorting, go back here. We're sorting percent correct low to high. That's not right. The people with the most percentage correct are the winners. We want those at the top. Okay, so let's sort it descending. Percent correct descending. We'll do that. Okay, we get the results, but oh no, the database can no longer use that index. Huh? Why? Well, the order the values are in the index no longer matches the order that we want them in our output because we've mixed and matched here. All right, so you can get around this. We can actually use the desk keyword in the create index. So again, like I say, there's a lot of, here's some I made earlier indexes. Let's make that index available again. We'll run this. So we got percent desk and hooray, we're back to a no sort. Job done. Wow. I said job done, but you notice there's still a bit of a problem here. Our nulls are still at the top. Okay. Let's just move them down, right? Let's just stick those nulls down at the bottom. So now nulls go down at the bottom. Let's run this again, but man, it's not just doing an index only scan anymore. We're back to having to read all the rows and sort them again. It's like, why? Well, the order we want the rows in the data set no longer matches the order they are in the query. All right, so what can we do about this? Now, unfortunately, you can't actually, or at least Oracle Database doesn't support desk nulls last for indexes, okay? So we can't just recreate that index. So how about we try this? If we negate the values percentage correct, we can do an ascending sort, so the nulls are last, because we're sorting ascending. And in effect, we get low to high sorting, because if you negate 100, minus 100 is less than minus 99, so it will appear first. So that gives us the sort that we want, but if we do run the thing, we find it doesn't use the index. So the index, like I say, the index order, the expressions must match the order by expressions. Okay, so if I make that a minus percent correct and do that, so now I've got minus percent correct, and hey, at last we're back to the no sort that we want. So key takeaway here is this order by is is quite sensitive to the index. They must match exactly, right? There might be a few. I'm always a bit careful. There's loads of really cool optimizations in the optimizer. It goes is way cleverer than we are. But as a general rule, you've got to have the where columns first. What's in the where clause first, and then an exact match for the order by. So notice minus percent correct seconds taken to get this index only scan and avoid that sort completely. So do bear that in mind. So if there's any questions or comments on that, bring those up. So just to kind of show, hopefully that might have been a bit tricky to follow. So just kind of show what's going on here, why the descending didn't work for nulls last. We create our index on column 1 descending, column 2. So descending sort has nulls first. So the null values for column 1 appear first in the index. And there is no nulls last clause in the index. So notice we've got null first here. Okay, so if I've got a query order by column 1 descending nulls last, then column 2, in order to kind of use the index, the database would have to start with value 3 and read through these values, then jump back to the start of the index to read the other values. The database isn't going to do that, right? Because it's all a bunch of extra work and it's quite kind of complicated. It's not going to follow that and do that kind of jumping around the index like that. It will work if the order we want the values from the index matches the order we want them in the result set. So if I make it a negative, if I negate it with an ascending sort, we go minus 3, minus 2. The numbers are actually 1, 2, 3, but we've negated them. Minus 3, minus 2, minus 1. Null is last because it's an ascending sort. And if we just do order by column 1, nulls last, we can just walk straight through the index and get it in the order we want there. So hope those kind of help make it a little bit clearer what's going on. And if you're still struggling, ask questions, let me know. But I was hoping, I see there's lots of questions come in while I've been doing that. So let's go and talk about that. Yeah, so people do more things on there. Does all indexes are default ordered in Oracle? So certainly all B-tree indexes are ordered data structures for all databases. It's part of the definition of what a B-tree index is. And the B-tree index is the default index in Oracle database, and it's the default in pretty much every relational database, as far as I'm aware, right? There are some more advanced index types which may not necessarily follow that sorting exactly, but as a general rule, it's worth assuming, that they are going to be ordered. But generally, the basic index you create will be ordered. Okay. Just going to limit. I've just checked the limit clause. It does exist. The limit clause does not exist in Oracle database. You must be using a different database. Okay. You might be using MySQL, which is provided by Oracle Corporation, but it is not Oracle database. Okay. Okay. Can I fetch X rows without order by just random X rows, and then what then with ties will do? Well, it will. Okay, so that's a good question. Why don't we try that out? So let's go. Let's get these rows. Nice thing about kind of thing, like, let's just comment that out with ties, with rise, with ties. There we go. So we're getting the first 10 rows for quiz ID 1, and we're getting with ties 10 rows. So we got 55. Let's see. Yeah. Let's see if we can get it to tie on something. No, this is going to be a bit annoying, isn't it? I know. We can sort... No. There is no column, but of course we don't know what the end. Yeah, actually, I'm not sure. I'd have to check this. It's one general point here is though you don't actually need the order by to use fetch first. Fetch first just means get n rows or percent. But if we don't have that order by, it's not sorted. So we don't know what order it's going to come back in. So let's see if we've got time at the end. We might come back to this one. It's a good question, actually. I don't know. Okay, question. Could you just quickly tell what all stats last adds the execution plan? So very good question. So you see, when I'm running, just get the plan again. So you notice we've got the plan. What it does is it adds these columns here. So we've got the start, how many times it did this thing. E rows is estimated rows. A rows is actual rows. A time is actual time. Buffers, consistent gets, IO, how much IO we did. So it adds these buffers, time, A rows, and starts column. And if it uses memory, the memory information, and then there might be other columns here that appear as well, which aren't necessarily appear. If we just do, if we do basic last, type properly, you'll notice those columns are all missing. We just get the basic shape of the plan. And we can do typical last, which doesn't include the row stats and stuff like that. So we just get the cost and stuff. So like I say, to really see how much work we're actually doing, we need to know A rows. How many rows did we actually process? Buffers. How much work did we actually do? So it adds all these execution stats to it. There's a whole bunch of these other flags as well. Usually I just use all stats last because if it's not processed, if there are no values, like you haven't used any memory, that operation, it just leaves it out. So I think that's pretty handy. So it's really useful for kind of understanding and checking that the plan gives you the information you need. Okay. In case we are not having the luxury of 12C or higher. The luxury, come on, like I say, you should upgrade at this point. I mean, the query I showed right at the very start is how you would do this if you didn't have 12C to kind of do that. Never heard of negating the sort. Yeah, I mean, like I say, you do need to watch because for that index ordering, but it does the job, right? Well, you want a descending sort with the nulls there. It's equivalent, right? So you think about that. What if the column is a varchar 2 instead of a number? Well, then it's going to do a numeric. It's going to do a do that. Let's get rid of that. It's going to do a string sort. So if we sort by 2 char percent correct, which turns it into a varchar, you'll notice it go 0, 1, 10, and so on, because alphabetically, it goes 1, 10, not 1, 2, right? Because 1, it sorts by the string values, so it sorts by that. So if it's a string, these numbers will appear not in the correct order, and it's not going to use the index now because I've 2 charred it, but otherwise everything else I says applies. Okay. If there's anything specific you wanted to know about string sorting, let me know. The negative will work for date-time columns having nulls. I mean, if it matches the sort that you want, it's the same principle, right? The nulls, if you can have negate date times, okay, which inverts the sort. I'm not sure. You can't negate strings. It doesn't really work with strings because, yeah, they don't have a concept of negating them like that. If I already have an index on a column and I create a new index for that column and other columns, will it affect the logic? Is it okay to have multiple indexes on the same columns? I mean, it depends. What do you mean by the query will still give the same results. It will affect the plan in terms of what's available. Now notice I've actually created a whole stack of these indexes now. and the queries all still work. I would advise not creating all these indexes. We'll talk about over-indexing in a minute, but having all these indexes does make things a bit difficult. All right. Oh God. Okay. I need to motor on. Okay. I thought that the row is not included in the index if all columns are, yes, all columns are null, right? Quiz ID is the first column, and that is mandatory. Okay. Yes. So in Oracle database, if all the columns are null, it is not indexed. Okay. Can this be solved by row num aggregation using partition by or using blah, 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 blah? I think, well, like I say, more time has passed than I realized. So I will come back to some of these late. It's the exact plan, same as so-called auto trace, similar. All right. Yeah, I'm going to have to move on. I'll move on and we'll come back to some of these. Can you please? And we'll come back to some of these a bit later. All right, so we saw fetch first, rows with ties, indexes. Must include the where clause, columns first, and then the order by. And a descending sort, the database can use a descending index scan and the nulls, but only if the nulls are first. Okay, so you need to watch out for that. So let's move on to the pagination queries. Okay, so you can do pagination with the offset clause. So this comes between order by and fetch. So skip n rows. So we do offset 100. What that means is actually we go past row 100 to row 101. So we get rows 101 through to 110. Okay. There are a few fundamental challenges to this, and actually fundamental challenges to all top-end queries, regardless of how you write them and regardless of which database you use. First problem is data anomalies, or inconsistent results, shall we say. So let's say we've got a little data set. We've only got pages with 3 rows for some reason, and we're sorting by column 1 ascending. We've got values 1, 2, and 3. I've run this query, got these results. After running the query and getting these results, someone else, you come along and insert the value 0, a row with the value 0 for column 1. So what that is going to do is push down all these results. So instead of 1, 2, 3, it'll be 0, 1, 2. I then click to the next page. What happens? This row 3 appears on that second page. I've seen it twice. Okay, duplicate data. Not great. Let's undo that. Let's look at a bit more of a worrying problem. Okay, we've got the same values, 1, 2, 3. This time, you come along and delete row 1. What does that do? It pushes all the values up. So instead of row 1 at the top, we have 2, 3, 4, 5, 6, 7, and so on. So that pushes everything up. I click next page. I see 5, 6, 7. I never see row 4. Okay. So, and there's lots of variations on this. If I'm querying through paging through a data set and you're changing it, inserting, updating, deleting rows, some stuff might go missing from my perspective, or I might see it twice. Okay. So what do we do about this? Well, one approach, the approach that a lot of us approach is like, la, 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 fingers in ears, do nothing, right? Put your hands up, admit it, we've all done this. We've all kind of ignored and pretended this problem doesn't actually exist. And to be fair, a lot of times you probably can do that. If your data set is pretty static, something like a product catalog, does it change every second of every day? Probably not, right? You can probably get away with it in some cases. But there are situations where you can't get away with that. And, you need to yes, people need to avoid these anomalies or duplicate or missing information. One way around this is to fix the data set. So what do I mean by that? Well, one approach is just to kind of cache a whole bunch of values, fetch 200 rows, 1,000 rows, however many pages you think people will query, cache those, and just page through that. Another is flashback query. So I'm not going to talk about flashback query in detail, but basically we're saying as of timestamp, before you run the query for page 1, we find the time, we record what time that is, and then we do the as of timestamp, and all the other queries for that search timestamp, we're fixing it to that time. So we get results with respect to the same start and time and avoid these problems. There are, like I say, there are other ways you approach this, but you need to think, how big a problem is this? What impact does it have? What can we do about it? Second problem, and problem, you know, we probably all came with, for the original question here is performance, right? And this is probably the more relevant or interesting problem. So now when I said it said offset, it skips n rows. It still has to read them. It still has to sort all of those rows. So if we go back to the original question we had here, someone saying fetching row 2 million is slow. We got offset 2 million. What does that mean? It has to sort 2 million rows. That sounds like a lot of work, right? No wonder it's going to be slow. So what can we do about that? Well, one approach, create an index with a where and order by clause. But that's impractical for free text search. You know, let's say you use the product catalog example. You might allow people to order by price, product name, and rating, user review. So that's 3 things for each search criteria you have. And who knows how many search criteria? Creating all those combinations of indexes, it's just not practical or possible, right? I'll talk more later on about various strategies here. So creating an index to match the pagination is only really possible or feasible if you've got a fixed where clause and a fixed order by, and you're always going to, you know, search on the same columns and sort in the same way. So what is another approach we can take? Well, let's say we're on page n, so we're getting row 2000. We remember what the value for the last row for that column. So we're sorting by column 1. Then when we go to page n+1, someone clicks next, we start the search from the row values after that, so after 2000. So we move to the next results. Because we know we're sorted by, we know we're going to move to those next rows. So we've automatically kind of jumped past all those rows in our data set. So we can do something like this. We can include that and show our result set here. This automatically jumps us because we know we're at, we've got to row n and it had this value. We can jump past that row and continue on working on down our data set. However, for this to work, column 1 must be unique. It must be part of the primary key or the unique constraint. Good chance the column you're sorting on isn't unique, right? It's not the primary key or unique constraint. So in that case, you'll have to filter and include the primary key or the unique constraint in the sort as well. Notice we have to do something a bit funky here like that. So what this means is we're no longer sorting 2 million rows. We're jumping straight to row 2,000,001 and then continuing on our data set. And this can be a really big performance saver. There is a big drawback to this, however. You can't jump straight to page n, whatever page n is, because we don't know what the value for the last primary key is on page n+1. So at this point, I will jump into a little demo. Okay, pagination. So let's say we've got the first 10 rows. Let's do that. And we can see row user ID 960 and so on. So just show last row here is user ID 90660, offset 10 rows, start at row 11. So we've gone on to the next user. We get rows 301, 310. There's only 309 rows, so we only get 9 rows. All right, so let's look at this consistent results problem. Like I say, the last user ID here is this user 90660. Okay, let's insert someone with a lower user ID. So the user ID is 10 something. They're going to appear. If we do fetch the next 10 rows, we've seen this person twice. They've appeared twice in our data set because we pushed everything down. Let's delete our rows. Let's push everything up. And so notice our top 2 rows here are 98% correct. There's 49 whatever user ID. If we now fetch those next rows, we've lost them. We've lost them from the data set. So one way around it, as I say, is to use this as of timestamp. And now we can actually see it before I change the data. I've done an offset to save me having to figure out what time it is and type it in and so on. In the real world, you would pick the time before I ran that very first query and fix it to that to ensure consistent results. So and they say this is a general problem for all pagination queries, however you write them. How you solve this and whether you solve it is kind of a bit of a business decision that you've got to decide and figure out whether you're going to deal with it. Okay, so let's look at the performance. Let's look at the more kind of pressing problem perhaps in performance. So we're going to get 10 rows. And notice I've not got a where clause here. I've got 14 million rows in the table. Got to read them all. Only sorting 10. Takes a couple of seconds. It's kind of slow to get 10 rows. Let's get 100,000 row, 100,001 and so on. And this is going to keep gradually getting slower. So if we saw, we used what, 4K of RAM roughly. We get 100,000th. We're using a lot. We're using 22 meg of memory, and we're processing 100,000 rows. It's getting slower and kind of gradually. However, at some point, you will hit the performance cliff. Okay. Let's fetch row 750,000 or go past 750,001. This query is going to take quite a while to run. So you can see it's thinking. So at some point, the database is no longer going to be able to fit this sorted data set in memory. It's going to go, it takes up too much memory. I need to write it to disk and page it to disk. And there we go. We've got our results. So you can see suddenly the query time jumps up to like 16 seconds. And we've got all these reads and writes because it's having to kind of process the data in memory, save it a bit to disk, process the next bit, and kind of read and write to and from memory consistently. Okay, so you will at some point hit this performance cliff as you work through the data set. So, the person saying row 2 million was slow. Like, this is why I'm completely not surprised. They probably hit this performance cliff point. And suddenly all bets are off. So how can we solve this? Well, let's see. We were on, we want row 7 million, whatever, 750,000. So let's remember our last row here. We've got 94.56%, and they took 250 seconds. So let's filter to do that. So we do that. We're going to jump straight to those values. And we can see the query is now back to a couple of seconds. I know, not perfect, but much, much better. But there's a problem here. If you remember, if we just go back up, our last two results there were user ID 14,000 and 26,000. And we've just seen those two people the same again in our result set, okay? Yeah. Look, remember what I said, if sort by the order by is not deterministic, we might see stuff twice or multiple times. So let's add the primary key to it, the user ID and the quiz ID as well. So we need to add these columns here, and we need to kind of do all this kind of crazy stuff here to filter those out. And this will take a couple of seconds. But now we are no longer including those in the results. And as you say, if we get the plan for it, you'll see, it takes a couple of seconds, but it's not 16 seconds because we only need to sort the 10 rows that we want in our result set. At this point, you might go, why don't they just do why do they do all this OR nonsense? Why don't they just do something a bit like this? Well, again, let's look at this result. We're going seconds taken 250, 251, 252. If I try and do something like this, up 250, 254. We've excluded a whole bunch of people in the results. Right, we need to kind of filter them out gradually to make sure we don't miss some data and miss some things that we should have seen. And again, verify that if we want to do that. So we're well past the hour. There's lots of questions, so I will kind of wrap up and then hang around to ask the questions because I recognize some of you probably got other things to get on to. So person said, this fetching row 2 million is slow. We saw some ways we can improve that. But as I said, partly I'm not surprised, but also who gets to row 2 million? I think it was page 4,000 in the query. They had 50 rows a page. They're on page 4,000. What person sees that? I certainly won't. You're not going to click through and do that. Why is someone, or it's almost certainly a machine, some kind of bot or some process reading that data? Maybe they should rethink the API. Maybe it's just a straightforward data download to get everything. Maybe there's a better way of doing this. I don't know because I don't really know the full background of the use case, but it's like rather than thinking about optimizing row page for row 2 million, it's like asking why is someone looking at row 2 million and how can we make that better and improve it. Okay, so pagination queries. As we saw, we can use the offset, go to row n+1 and get the rows from there. And this is part of the SQL standard way of doing it. Some other databases support this as well. Any type of pagination queries, however you write them, can have these data anomalies where inserting and updating, deleting rows can affect what you see. What do you do about it? Well, you could just ignore it, or we could use the seek method. That means if someone inserts new rows, we're not going to see things twice. Things can still go missing potentially as well, though. Performance, again, we can have indexes to match the search, which helps as long as our query is fairly static. And again, the seek method is better, more reliable way, but it means we can't jump to row page n. We have to kind of page through the results one by one. So this kind of works quite well for infinite scroll. You know, a lot of social media things, you just keep scrolling. So you don't actually see the pagination. The seek method works quite well for that because you just keep going. And when new information is enough new data has arrived, you get some notification, there's new posts, and you can go back to the top and start again. Alrighty then. So we saw top end pagination queries. We've got to sort, if you want the data to do these reliably and correctly, you need an order by. You've got to sort them. Think about ascending versus descending and where nulls should go in the results. Make sure you set those appropriately. If you've got expressions, formulas that you want to order by, and particularly if you want them to select as well, use column aliases to sort by those. The top N, we've got the fetch first syntax, which allows you lots of options to set, say, a specific number of rows, percentages, whether you're going to use get with ties and so on. And then with pagination, again, think about those data anomalies. What happens if people change the data while someone else is paging through it? Doesn't matter. Do you care? What's the impact? I don't know. You got to figure that out. And then when it comes to performance, indexing will only get you so far. This kind of seek method is a much more robust and reliable way to kind of jump to page n or continue from page n in a result set, but you cannot jump to page n. You want to know more about SQL performance tuning generally, like I say, got the free SQL performance tuning course on DevGym. So databases for developers for performance. I talk about reading execution plans, indexes. Check that out if you want to know more about that. And I will be back next month for the SQL office hours to kind of talk about that. Like I say, I see there are a whole stack of questions. Stick around if you want to discuss this more. Save for the answers, but for the recording, I'm going to say goodbye for now. Those of you who need to head off, and I will see you next month for the next upcoming office hours. Goodbye.